Hi, welcome to the Libra licensed vehicle, ultra efficient vehicle design. Part 2. I just wanted to go over the joint system, which is a critical part of this design. Using Calfee design bamboo bike technique and a combination of that with Divergent 3D Microfactories node system, what I'm doing is some joints such as this one into pipes. Let me just de-iconize that, otherwise it will go recursive. So what we have here is a central ball, which will be a cast hollow structure to save on weight, or it can be plastic 3D printed, or it can be metal 3D printed. So that'll be I think if you're doing it metal 3D printed, you can do the whole lot, including these pieces. When casting, each of these cone-shaped pieces which go into the ends of the pipes can be done separately, and then you can have a jig which holds each pipe for each of these nodes, where a whole batch of these pieces will be available, and you just assemble them. It can be done with a robotic arm, etc. That's I think all done by hand. Of course, with 3D printing, that's not an issue. Just do the whole lot. So the whole point of this is to be variable from self-assembly, self-manufacture, right the way to full mass production. Now this won't be the final design, but it's just something that's temporary at the moment. What the plan is to have a hollow ball, and then instead of the smaller ball have a capturing system. So in the end of the pipe you would put a locking thing where you push it into some slots, like a key. Take a key and you put it into a lock. Now I imagine 3 keys sharing the same shaft. So 1, 2, 3, all 120 degrees, the bits with the actual keys, which go into like a triple hold lock, and then you turn it 60 degrees, so you have separation by 120. Goes into a thing, turn it 60 degrees, and it will lock the pipe, key-pipe in place behind there. And that actually, if you make sure that the locking arrangements at each end of the pipe are in the same, the opposite direction. So at the left end is clockwise and at the right end is counterclockwise turn. You can actually disassemble the entire thing. So during assembly, you just twist one of the pipes into place, or if you make a mistake or whatever, something needs altering, you just you can twist it out rather than having to cut the pipe or undo the end bit. Now these end pieces, the intention is to screw them into the end of the pipe. So on the inside there will be some threading thing, and then just like in the Calfee design, bike design, you take some resin covered cloth and wrap it around the whole thing, and bind everything together. Right, once you're happy with the whole thing. Now I thought it's really quite difficult to do here, but I just wanted to give you an idea of some of the things. From this end, this is the air box here. There's one at the top and one at the bottom. Formerly I had all of the struts down this center here, going from front to back, they were formerly all slanting from top right to bottom left. I quickly realized that at the joining point, let me zoom in on one here. At the joint point here, what happens, unfortunately, if you do that, is that there's a pipe. This pipe here, if you have another one coming into here, and there's a clash. So what I had to do instead was have this pipe going to here and that pipe going to that one. So you get the cross hatching that you see here. One of the pipes goes from top right to bottom left, with the other one that's connected to, offset by one, goes top left to bottom right. That system, and that when you look at it, the one that goes from top right to bottom left is this one, and the one that goes from top left to bottom right is that one going to the bit thing. So one of them joins the same x coordinate things in each row, this way, forwards and backwards, and the second one joins the thing, and that way you end up missing the things and you don't get a clash between the joints. As apologies, it's terribly difficult to see this even when rotating it because of the other things in the way. You can see I've removed some of them. I'm just having to go through and inspect every single one of these joints. I'm currently on what I'm called the rear box, and we just have to go like this to get to zoom in on, say for example, this one, and then we can rotate to check. Here's a clash, because I've been doing all of the brown ones for what's called the rear box. The green ones are for the rear section, and you can see that these two pipes clash. Okay, and these two as well, just here. So I created an auto joint system which, given the angle that the pipe is at, will actually automatically locate the suitable position for the attachment point, so this one to be joined on. So there are around here, there's 1, 2, 3, 4, 5, 6, 7, 8 positions around here on the horizontal plane, and then there's an additional in the horizontal plane will be around the z-axis, around the y-axis there'll be another 1, 2, 3, 4, 5, 6, excluding these two already, and then a couple more, well several more actually, I think, but basically there's positions that pipes can be attached here, and the automatic system, I was spending far too much time trying to manually lay out, this one comes in here, this pipe comes in here, therefore, and this one needs to come in there, and that one is just a mess. So an automated system, and finally narrowing these pipes in with a cone system will give both the strength and the thing. So I believe I'm now happy with all of the brown pipes for the rear box. I need to move on, I think, but it's just one at a time, inspect them here. Okay, now we need to go up to this one here, so bring that down to the center point, rotate through 90 degrees, and should be able to zoom in. Yes, that was that one. Okay, so let's have a look at this one, and you can see none of the pipes trying to occupy the same space. These two are okay, those two are okay. That green one there is a little odd, but that's okay, at least it's not clashing the space. No, I can't see any pipes overlapping on there, not even the green ones. Excellent. Zoom out again, and go turn it so that it's side on, and bring this point here. Now inspect this one. Ooh, that's very close there, but it's clear, so that's good. Ah, got one. Right, that occupies the same space. So we just have to sort that out. Let's have a look at that. Right, which pipe is that? That is the one on the bottom. That's this pipe from here to here. Yeah. Hang on, wait a minute. Bring it side on. Bring it up to there. Let's have a look at this end as well and see if that one clashes. No, that doesn't clash on that end. However, it's not going to be good enough. Let's have a look. Where can we take that? So that one. It's this pipe here that goes from there to there. Is clashing in that space there. And I think what the best thing to do is to move this pipe, one going from here across the center point to there, and turn it so that it goes from this central point to that one. Okay, so let's identify that pipe. Let's go to the code. Now what would it's actually easier to do it by process of elimination. You'll see in the code on the top right hand corner. Let me just expand this to huge. Return that and run the thing, and some of the pipes should disappear. Yes, they do. There we see. Now the roof line. Okay, now process of elimination again. We're adding some in. Aha! So inter roof pieces horizontal forward, and it's going to be this one. That's the one. There we go. Right, so what we want to do is go instead from roof I+1 to the base, and let's see what happens there. Ta-da! Interestingly, that does all of them, which means we have to change the thing. So what we're going to do instead is this. If I equals 0, that, else +1. So we're going from top to bottom on those layers. There we go. Nope, not that one. If I equals 1, if I equals 2, there we are. Brilliant. Okay, so that pipe is now going from there to there rather than there to there. Watch that. Equals -1. Okay, so let's just, that will be always be false. So there we go. That's the one that we needed to flip over from those two to that. And now let's have a look at let's inspect this point here. Bring that in to there, and now we can zoom in on it here, and if we look at just in there, that's missing. Hey, fantastic. And let's have a look at the other end. Yep, that's clear. And now let's inspect this one again, and let's bring that in, turn it through right angles, rotate, there we go. We found another one. Just on that roof point there, just here. So we'll do that one later. Can you see there's maybe those two touching? Those two here? Behind that, let's spin it round. Yeah. No, they aren't. We're looking upwards through the bottom of the car at the moment. No, there's no way I would want to compute this sort of thing in software. I mean, you could run some software which will. We're looking to the front of the car at the moment. That's to the side. We could actually compute this using some software which calculates whether these are clashing or not. To be honest, I'm not that keen on doing that. It's 3D calculations and etc. With what clashes with what, etc. Yeah, it's a lot of work. Just before we go, I'm going to have a look at these ones over here as well to make sure that this, yes, that one has been changed to go in that direction as well. That's the other side. And have a look at this one as well. Despite the fact that some of these are symmetrical, they're not actually in some cases symmetrical, so let's inspect the gap between those two here. Yep, there's nothing clashing there. See, that gap is missing each other. It's not actually symmetrical, so we do actually have to inspect every single joint. Is quite ridiculous. I'm amazed and I have a huge amount of respect for people who do 3D vehicle design now that I've done this. I'm honestly not surprised the cars cost so much money, such amount of money to design. Gotta bring that down, guys. Anyway, thank you very much. I'll go and fix that purple one if I can find it. Thank you.